Jump came to you are given zero indexed array of nums of length n, and you are initially positioned at num 0 means starting position. Okay. Each element in nums I represents maximum length of jump. So okay. Uh, to move forward, take forward jump from index I. In other words, if you are at nums I, you can jump to any nums I plus j, where j would be in between 0 to nums of I, and j plus I plus j would be smaller than n. Okay, return the minimum number of jumps to reach at this position, which is basically means end of the array. Test cases are generated such that you can reach at the end. It means there is the solution, there must be the solution at the end. So the basically we have given an array, and in array every element represents a maximum length of the uh, jump that we can take to move forward, and we have to reach at the end of our array with minimum number of jumps. So we need to make sure we reach at the end with minimum number of jumps. So this is the example. If I take this example to visualize this problem, this is in the first element. This is the first element, and this is our starting position as per this statement, and it means two represents we can take two jumps from here, either one or two, because it's up to us. We want to take two jumps or one jumps. Maximum we can take only two. So it means we have two possible choices. One and second possible choice. Let's say if I choose with one jump, then I will be here, and here I have three different choices. Three jumps I can take, two jumps I can take, or one jump I can take. So one choice, two choice, and three choice. So let's say if I go with first choice, take only one jump, then I will be at this with this number of jumps, which is one. And if I take this one jump from, because this is only one choice, so take this one choice, and we will be again at one, and again take this choice, and we will be again at four. From here we have four choices, but this is the end. We have reached at the end. We don't need to go forward. Okay. So now if we see to take the choice, second choice, which is from here, second choice from here, take two jumps instead of one. So if we take two jumps, we will be at one index of one. We have next one jumps available, and if we choose that one choice available, we will be at the end, and this is the final end. So if we go with the taking all three jumps at a time, so we will be directly at four uh, available jumps. So this is the for completed for all possibilities. I have just try to visualize how what will happen if we take all different possibilities for these three, and what if we take second possibility for these two, to take two jumps instead of one jump. And if I take two jumps, I will be at one, and I will be available one jump to take. And if I take this one jump from here, and there is again one jump, if I take another one jump from here, because the jump variable is one, so it will be at here. So if I count down the number of jumps it takes to reach at the end of the array. So one jump, two jumps, three jumps, no, not three. This is two basically. This is three. This is four. So total four jumps. this path took to reach at the end. And if I count down this one, two, and three, it means this took three jumps to get at the end. And this path only will take two jumps to get at the end. And the final path, one, two, and three. It will take three jumps to get at the end. So what is the minimum number of jumps to get at the end? This is minimum, which is two. So this is our answer. So we have to return this answer, which is a minimum number of jumps to reach at the end of the array. So if we go with the solving problem with this approach, like uh, this visualization, like trying every possible path or possible uh, combinations we have, uh, then it will be not much efficient because the nums of I range is from 0 to 1000. If this range is a bit smaller, then I think, but even if it is smaller, it is not that efficient to solve with this following this tree, following this every possible combination. So how it can be solved? So let me see. Like we have to reach at the end. The one goal is to reach at the end. The second goal is to with minimum number of jumps. So if let's see if I have this path and I'm starting here and my goal is to reach at this destination and how I can reach. But my also one goal is to reach at this destination. Let's say I just want to reach at this destination. So if I want to reach from starting from here, let's say I take these steps or jumps. I'm just thinking like how I will reach from here. I am standing here and I want to reach here. How I will reach there. So let's say I take jump or step, whatever I call. Um, both are same, like I'm saying same. Let's say I take one jump here, I take two jumps, then I take three jumps, and I am at my destination. It means I took three jumps to reach the destination. Let's assume that this every jump have a value. Let's assume this jump has three values. I'm just assuming it. This jump has three value and this jump has three value. So what if instead of I am taking the uh, a jump of maximum length three, and what if I take a jump of maximum length six, which is the double the length of previous one. So what if I take the jump, this is a sixth jump of length six, this is another jump of length six. So this is the sixth length, this is a sixth length. Again, if I count both of the total, and it will be around nine. So it is nine. If I take the um, if I took the double of the length above, total is 12 basically. If I take double length, I have overall jumps. I have two. What if again just I'm just assuming that I am taking double the length of this one. So uh, then see 12th length, I have 12th length jump. Means maximum length of the jump I have is 12. So if I take 12 length jump, it will be like this complete. So it will be number of minimum number of jumps I take from starting to end is one now. So it means if we prefer to go with a value that is that has larger length, then it is good for us. Why? Because if we take the because we want in the example, in the question, we want minimum number of jumps, and we also want to reach at the end. So where is the minimum? If I see my realization, where is the minimum number of jumps? This is one jump, one, and this is one result, and this is a third result. So in the third result, we have minimum number of jumps. So it means if we prefer to go with the maximum length, maximum or larger length, then it is good for us. If we go with larger length, we will jump larger or bigger. We will take bigger jump, and we will get more closer to our destination, and it would be good for us. So in I think this kind of approach we can apply same on the our problem. So to solve, so let's say if I run this run the same approach on the example. Uh, this is the destination. This is where we are starting. And what if I start from here, and I know that I have only two jumps. So now my question is, in my mind is that should I choose to jump or not? So should I choose to jump or not? So because we are starting from right from like zeroth index. So we can think of we want to take this jump, and let's say if I take this jump, and I will be at this position. So from this position, let's say I will be reached at 0, 1, 2. So 0, 1, 2. Let's say I will be reached at 2, second index. So I can just do a bit bigger. So I will be at this position, and after taking two jumps. So I'm at here. So this is the question is, should I take this jump or not? So when I should decide to take jump, when I should decide to just do not take this jump, because uh, I will only prefer like to jump bigger. So initially I don't have any jump that from with which I can compare like this is the bigger, and I should take this bigger jump because I don't have any larger jump. So I will consider first jump to take because this is the only larger jump I have. So so largest, I can say largest jump I have initially. So I will definitely take this because this is the only largest jump I have initially. So I will take this jump, and it will be at there. So after jumping, we can count jump one. So we are only preferring larger. So this is the one jump. So we can set a variable that tracks that track our this jump we have taken now. So we can have a variable that will track this one. But as I just took a jump, uh, and I utilize this well jump length only, and when I should decide I should take this second jump or not. So first I need to check this jump is larger than previous one. First I will check this thing. So yeah, 3 is greater than previous jump, which is 2. So if I add up the current position of 3, current position of 3 is 1. So if I will jump from 1, I will be at which position? I will be at fourth position. So it means jump length is good, which is larger than a previous jump, which is 2. And if I take the jump from current position, which is 1, I will be at fourth position. So let's say after the let's say I'm just assuming if I take a jump and I will be at end, which is the position 4. which is a position 4, and jump length is 3. So what next to do? Like, because I just thought that if I will prefer only larger jump. So initially I prefer this jump to then because I this is the only largest jump I have. Then in the second element I got another larger jump which is greater than 2 previous jump length 2. uh, I will now calculate the expected destination, which is 4, uh, which is 4. And now the thing is how I should make sure I should make jump up till this. So to make sure we should take this jump, use this length, jump 3 length, use this jump length 3 or not. This is the question. We should use this 3 length jump of length 3 to move forward or not. We only want to pick this jump length when there is not any element, any jump length greater than 3. So if I see here, we can set a variable previously, like here, that will float over here up till 3, up till this point, up till this position, update this position, which is basically 2 position. And we will check in between this range. If there is any element that is larger than 3, then we want to consider that larger element instead of this 3. So if there is not any larger element, then we are reached at this position, then we will take the jump. So if I see in my input array there is a 2, there is a 3, there is a 1. So our one variable after taking this jump length of 2, uh, we will be at here. Uh, our one variable or one iterative will be waiting at here. Let's say I call it as end, or I can call it as last. And then when we are going to decide to take this jump or not, we need to check in this range of elements whether is there any element that is larger than 3. If that is the element, then choose that element instead of taking the jump with 3. So there is not element, and when we will be reached at this position, we will then take the jump. So why? Because there is not any element between the range that is larger. It means 3 is the largest. So take this jump, and that will make us more closer to our destination. So I'm going to take this jump now, and taking this jump will count jump as from 1 plus 1, which would be 2. Now, if I see, I after taking jump, I will be at let I will be at the position number 4. So which is basically the, if I see input array, position 4 is the end of the array, 0, 1, 2, 3, 4. So position 4 is the end of the array, and we are reached at end. We don't need to move forward to check or anything. So we don't need, we can just return a number of jumps we have, which is 2, and this is the minimum number of jumps to reach at the end. So how this works basically, uh, this basically choose the jump to take that is larger between the range that is mentioning last and end. And also we just need to uh, think of the variable that tracks jump we have taken, last jump we have taken. For example, if we took this jump of jump length 2, then our last variable will be at here, and variable will be at here. If we take the jump of length 3, and our last variable at will be pointing at here at the position at the position where our after jumping we will be at. So just like this position, I'm mentioning this position means this position. After taking jump, we will place our variable at this position, and then we will see in between the this range, is there any jump that is larger than current jump length we have. So if that is the only larger, then take the jump. If that is not the larger, then uh, go with the another other larger jump. So that this is how it will be work. So I'm yeah, I think I should write the code to make things okay if it works or not. And I tried it before as well, so I will try again. So first I need a variable jumps that will uh, track our number of jumps, like answer, that would be our answer. Then I need a variable next. I can call it next large jump, or I can call it as uh, closer to destination, something like this, or next jump. Uh, I'm calling it next jump, or next largest jump is fine. And initially it will be at 0. Initially it will be 0, and then I want to take another variable last jump, uh last position. I think last position would be better, because this will track basically if we are going to jump, then what was the position where this will be at, or we can simply call it as position as well. I'm calling it as 0. So starting to find with I should be less than, I think, one more variable to take n nums price, and we want to go up till end and increment by 1. Now thinking of calculating next jump. So jump so next jump next jump means where our we will lie after taking jump. This is the basically this position, mentioning this position. Next jump means this position. So if I say it this variable instead of next jump, I can. Okay, I'm just not going with variable names. I'm just writing code. Next jump, max of next jump with current jump length we have plus current position we have, and initially we will get initially 2 is the largest jump, and we will be going to take this jump. So how we will decide we should take this jump? This condition will decide if we are at starting position, if we are at position that is same as last position or last jump we have taken so far, uh, last position of jump where we were present. So if that is the case, then count take a jump, then take a jump, and then take a jump, and also set the new last position as next jump. So we are setting last position now. Now the current jump, next jump position. If I simply call it a next jump position, next jump position now would be our last jump position now. So okay, now if I need a check here, if I reached, if I see that I got reached at end, it means we are reached at end position, so we don't need to go further. We can break. So in the end, we can return. In the end, we can return jumps. So for run this. So this is how we are solving through a greedy approach. So we are only preferring largest sum, and in between the range we are checking if there is any, any jump, then take jump. Otherwise, if we reach at the index last position or last jump taken, then we want to take that jump and go with uh, next one. So this is the thing, like it how it works. I just want to visualize it. So if I am at starting position 0, and if I see here is the two jump, and I can visualize is the next jump position would be, let's say, 2 plus 2 plus 0, it would be 2 plus 0, it would be 2 plus 0, it would be 2. So next jump position would be 2. So this is the largest jump we have so far now. So if we see this condition, I is 0 initially and last position is also 0. So because this is the starting and we are considering this is the largest jump, 2 is the largest jump we need to take. So we will definitely going to take this jump. So we are going to take this jump, and this is the one jump, and we can count it as one jump. Now our last position is this position is the last jump position. Last, I'm just taking variable L, last jump position, and our jump is the one. So if we see this condition, last jump position is not at end. Yes, last jump position is at 2 index. It is not the end of the array. So we are going, this is false. Again, if I check next largest jump, now next element is this 3. So 3 plus 1, 3 plus I is 1 would be 4. Now 4 is 4. And next jump was previously it was basically 2. Now 4, and 4 is the next, like taking max 4 we will get. It means next largest position would be 4 here. And now we need to check in between this range. Is there any position that makes us more closer to our to the uh, destination? Then we want to choose that. Otherwise, we will go with jumping this. So again, we will see if next element 1, which is 1 plus 1 plus 1 is 2, and 2 is not greater, and it means also we need to check I is 2, and 2 is same as 2. Then we are going to take jump, and the last position would be now this, and it will take a jump. So jump will be 2. So if this is not a case, let's say if this is not the case, what will happen? We will just ignore this element and we will move forward and check this. If this again this case becomes false, I'm just assuming. So again, we will ignore. So unless this case is false, we are going ignore elements. Then we will only, because we are only considering this, looking for the greatest element in the range, last and last position and index. So current index and last position. So this is how it works. Greedy approach, using the greedy approach.